Okay, section 4.6, situations that always or never happen, and this can apply to equations or inequalities, so we'll take a look at one of each type. And really what you have to keep in mind with this situation is that these equations should seem sort of obvious, so you really just want to stop and think, okay? But we do want to look at, in an equation, what would occur to make that happen, to have a situation where there are no such x's that would solve this equation, or where it might seem to be impossible. So remember that when we're finding solutions, okay, like the ones we did with the tortoise and the hare, and some of the ones earlier in the chapter, we get two lines and we're looking for that point where they are equal or where they would cross. We could talk about when it's greater than or where one line is less than the other, but the solution is that point of intersection. Okay, and so that's a really important concept to keep in mind. When we're solving things and we have two equations, we're trying to solve both of them, we're looking for that point where they turn out to be equal, or where they're the same. All right, so we look at Auburn Hills and Grand Ledge, which is on the other side of the state, and write an equation for each of those. So Auburn Hills, we could say A equals 180,000 that it's starting at, a constant, and that it's growing by 1,000 every year. Okay, and so here what we're going to find is when will one city catch up with the other. So when here is really years. Okay, how many years is that going to take? So that's our x, define our variable. X is years. Okay, for the other equation, we got Grand Ledge, and so G is our 40,000, and it's also growing. Those are important words to pay attention to if it's increasing or decreasing. Also increasing by 1,000, and so we can kind of look at this, and we already know what's going to happen. Okay, they're both increasing by the same. Auburn Hills is already way ahead. Okay, but let's just kind of go through the motions here of showing you what actually happens when you try to solve an equation like this algebraically. So we set them equal to each other and we solve, and you can probably kind of guess here what's going to happen when you subtract. We would get our x's on the same side. When we subtract 1,000, everything kind of disappears, so our x's go away. And you have to not doubt yourself when that happens. You have to just kind of step back and look at it and say, whoa, did I just set that up right? But when this happens, and it will happen now and again, what we end up with is an equation that is obviously not true. It is 180,000 equal to 40,000. And so what you're doing now is you're asking yourself the question, is this thing true or false? And so this is definitely not true. Okay, and so these are not equal. And so we have this unique situation here that all of the variables just kind of dropped out, they canceled each other out. And what happens is that false means that there is no such year. There is never going to be a year or a time when, at this rate, Grand Ledge is going to catch up. Okay, so just kind of quickly, let's think about what a graph would look like. 40,000, and we'll kind of abbreviate here a little bit, but 40,000 and 180,000. And then think about increasing by 1,000. Okay, so if we start here at year 0, and we go up by 1,000, we're growing at that rate, up 1,000 for one more year that we go. And starting at 180,000, we do exactly the same thing. We go up 1,000 and over, and we have two lines that are increasing at the same rate. And so what do those lines look like? Okay, what kind of lines are they? And so they would be parallel lines. And so what solution would we have? When are they going to be equal? Never. So when we have a false answer, there's a bunch of things we know. We know the lines are parallel, and we also know that the solution, if we're trying to solve for an x, we know that that solution is going to be no solution. There is no such time. okay? Same thing is true, like I said, with inequalities, okay? So two friends have birthdays on the same day. Chris is 13, Austin's 14. In how many years, again, will Austin be older than Chris? So that older than, when will Austin be older than Chris is what we're really trying to ask. And so Austin is 14, and if we add on a certain number of years, and we take Chris's age, 13, and we add on the same number of years, because every year that goes by, they each have the same birthday, so they're getting older at exactly the same day. And so now we have, again, this little equation that if we subtract x and we try to solve, right, we kind of get right back where we started from. Those x's drop out, and we have this equation, or inequality rather, that 14 is greater than 13. And once again, we want to ask ourselves, is this true? And yes, it is. 14 is bigger than 13. 14 is older than 13. And so this case, when we get a true answer, that means that for any x, for any number of years that you add on, you go 20 years down the road, they're each going to add on 20 years. Austin's still going to be a year older than Chris is. So when we get a true statement, that's where we have all real numbers, any number of years, 10 years, 20 years, 100 years, are still going to be in this relationship where Austin is greater. Okay, 14 is always going to be greater than 13. Okay, so two special cases. And this next part you can just kind of watch. There's nothing really for you to fill in. It's already all filled in on your notes. Okay, so these are our two special cases where when we solve the equation and we get a true statement. So these are kind of set up in columns here. So look back at what we just did when we got a true statement. What was the solution? No solution or all real numbers. Okay, so we got all real numbers as our solution. And then the graph, okay, we really didn't talk about the graph here, but the graph is going to be where our two lines would actually be the same. They would be exactly on the same line. Okay. And then our other possibility is that we get a false statement. And when that happens, the solution, okay, again, talking about the solution is no solution, that's false. And in this case, what would the graph look like? Well, they are parallel. They never cross. So there's never a time when they're equal. Okay? So we can look at the type of equation or the inequality that we get. We can decide if that statement is that statement that you get when you solve it, a true or false statement. And then that's going to lead you to what the solution is. So all these different ways of kind of talking about our answer. When we solve it, we get a statement. We can translate that into a solution, or we can then look at what the graph would look like for each of those situations. Okay, so a bunch of different ways to kind of talk about a fairly easy, fairly straightforward concept here. Okay. All right, so once again, this is the part you don't have to write down, but just another way to look at this. Okay, so if we get a solution here in the middle in black of 4 equals 4, we're asking ourselves, is that true or false? And then the red button up there says, yep, indeed, that's true. And then our solution would be all real numbers, that fancy R. And over here in green, the graph then is one line. They would be exactly on top of each other. When we get a false statement, okay, so we get an equation where 5 does not equal -3, that's false, then our solution in our graph, okay, no solution, and therefore the lines never cross. There's no place on the graph where they're the same. And so we get our two little descriptions there. So let's try it. Okay, so here's what you're going to have. You're going to have some equation or some inequality, and you're just going to go about solving it. And we want to see, in the end, maybe how to interpret our result. So on the right-hand side, we have to simplify. The left-hand side, we need to, there's nothing on the left-hand side. The right-hand side, we're going to combine like terms, so 4x. And then for all the ones similar to all the ones we've been doing here, we look at 4x and 4x and they're the same, so there isn't one that's less to start with. And so sure enough, 4x minus 4x on both sides just kind of drops out. And so now we have negative, now remember, don't lose that negative sign, negative 13. Is that greater than 26? So when the variables all drop out, you have to interpret this answer. So 13, negative 13 is less, is not greater than, so this is false. And so then what would our solution be? So look back at those little bubbles that we just did. The solution then is no solution. There is no such x that will ever make that statement true. All right, the next one, nothing to do on the left-hand side. Over here on the right-hand side, we need to distribute. 0.34x is less than or equal to 0.34x, 17.17 times 2, and then times 10, move that decimal point over one place. Right? And so here we go again, we subtract and get our x's on the same side. And so we get that all of that cancels out. And so 0 over here, you got to put that 0 in there because you need something on the left-hand side. So don't just leave it blank because you're going to compare. Is 0 less than or equal to 1.7? And it's an or, less than or equal to. 0 is less than. So this is true. Alright, so remember we're asking ourselves that question, is that thing true? And so our solution in this case is, when you get a true answer, all real numbers. Plug any number you want in there for x, and this original statement, whatever you plug in there, on the left and the right hand side, it will always turn out to be true. Okay? So the thing is you don't know that that's going to happen when you've got a bunch of problems on the quiz or on the test. You don't know, looking at it at the beginning necessarily, that situation is going to happen where the variables all pop out, drop out. And so you have to, when that happens, kind of take a second look, make sure you didn't make a mistake somewhere, but don't freak out when the variables all disappear, because that's going to happen every now and then you have to interpret that answer. Okay? All right, there's the odd questions that you're going to work on, and we will take a look at the rest of the chapter when I see you again on Monday.